So we have Kelsey Hightower joining us, developer advocate from Google, Brendan Burns, distinguished engineer at Microsoft and one of the founders of Kubernetes. We have Joe Beda from VMware, and also one of the founders of Kubernetes, and Brian Grant, who's coined the term Kubernetes resource model, as I understand it, and is currently a distinguished engineer at Google. So Kelsey, I'll pass it off to you.
Awesome. So we'll kick things off. And I think when people look at cross-plane and this concept of a control plane, it's real easy to get a bit confused. You say, hey, isn't this configuration management all over again? What's the difference between this and just using Terraform, Puppet, Chef, or Ansible? So hopefully today with this panel, we'll be able to dive into the details of like, what do we mean by control plane? And also what we mean by control plane that happens to be implemented on top of the Kubernetes resource model. So we're going to be welcoming our panelists today, and we're just going to jump right in. We don't have a lot of time. And for a lot of people, you may not know how this whole Kubernetes control plane kind of concept came about. Of course, it's the API that we use to interact with Kubernetes. But I want to give this first question to Brendan Burns. I remember visiting Seattle and him calling me over to his desk to say, hey, I want to show you something. What if everyone could make a native Kubernetes API and all they had to do was provide a schema and we would do the rest? Brendan, if you could actually talk about maybe the origins of the CRD, your thoughts on how it's being used and what role it plays in this kind of control plane approach to managing infrastructure and applications.
Sure. I mean, I think that there are two aspects to the CRDs. They're called third-party resources originally. One is I think there was a broad understanding as we got into the community that having extensibility was going to be super important. I think partially this is because we were working with the OpenShift folks who are building stuff on top of Kubernetes already, even from the early days. And so it was just very clear that extensibility was important. But I also had a lot of like recollections of my own Linux experience where, people were inserting modules and we were writing modules for the Linux kernel and extending the Linux kernel, oftentimes with stuff that actually Linus hadn't accepted yet, right? And so it was really important to have that extensibility and that ability to kind of build extensibility outside of the core, right? And really without asking for approval in order to support some random hardware device, or like we were doing robotic stuff, and in order to have our custom ASICs work in the Linux kernel. So that kind of extensibility really felt like it was critical to building a good ecosystem. And then the origins of the third-party resources also come back to, I would say, my experiences teaching CS 101, where it just was very clear that like you have to make things as easy as possible to get the breadth of developers to come work with things, right? And so there were competing proposals for how to extend the API server, but it was obvious to me that in order to build a broad ecosystem, it had to be really, really easy. And that was sort of the origin of this dynamic idea that you could just kind of inject a module in, have a new API show up. And again, it was to make sure that like because we were already seeing lots of pressure around like what APIs are we going to add? Like, and you can easily imagine like with Crossplane, if somebody came to the Kubernetes community and said, hey, I want to add APIs for every single cloud provider, it's just not going to work, right? Like, no, it would be insane to do that into a single project. And so, just having that really, I think, freed people up to do things that are useful, but maybe not useful to the sort of 90% threshold of Kubernetes users that is required to get into the core. So.
Yeah, and I have a follow-up to that. How much did we learn from like the OpenStack community and the Docker community, where I think they felt a lot of this tension of defining these APIs kind of well after the success of those projects?
Yeah, I mean, I think absolutely. We looked at those communities. We talked to a lot of those people all throughout. OpenStack in particular, I think we talked a lot about and thought a lot about because one of the things we saw also early on was a bunch of vendors in the both networking and storage space kind of piled in. And like we had, I don't remember if people remember, but like we had all these in-tree, like in the pre-CSI days, we had all these in-tree storage providers, and like it just exploded. Like people kept trying to merge code in for supporting their NAS or their iSCSI or whatever it was. And it just like, there's a lot of lessons like that where it became very obvious that you had to have a pressure relief valve, either the right kind of interface so that people could implement it separately. Or, you know, in the world of APIs, that interface is these CRDs and the ability to sort of say, hey, abstractly, I know what an API object is, but like, you don't have to tell me about every single API object that exists. So.
And I think going from there, Brian Grant talks a lot about the foundation of the Kubernetes resource model is kind of rooted in its schema. There's a big nuance between, you know, config management, infrastructure as code, you know, infrastructure as data. Brian, can you kind of shed a little light about why is that schema so important, and the fact that we have to start thinking about this stuff as a data model versus just running automation tools within our environments?
Yeah, and one of the first things I did in the Kubernetes project is add support for, you know, after we open sourced it, is add support for exporting the schemas via Swagger, and that later evolved into OpenAPI. And that's really been useful in many ways. It allows tools and people to discover the supported fields, the schemas of the resource types. And that creates, you know, it has similar benefits to strong typing in coding, that you can, you know, understand what the features are of a type, and you know, what data types there are, what the validation, what values are actually permitted, what fields are permitted, and so on, and understand what their semantics are, and then build on top of that. And what we see in the infrastructure as code space, or with scripts, or, you know, deployment tools, is that there's not enough standardization around what people are doing to have that level of certainty. So it's very hard for one team or one organization to build on something developed by another team or another organization. Even if it's open source, we see a proliferation of open source deployment tools in particular that have a lot of overlap, that do similar things. They don't build on each other. They kind of reinvent the wheel. And I think the lack of well-defined APIs is part of the reason about you know, why that happens. So in the upstream Kubernetes project, we have these built-in types and lots of things built on those types. In the ecosystem, using these API extensions that Brendan talked about, you know, people are able to develop their own types. Some of the vast majority of those types also don't get built upon, but the ones that are valuable to for multiple different users and use cases are able to be reused, and, you know, the people who are building on them can understand what the contract is. So that has really allowed people to start build up platforms like Crossplane on top of other systems. And I'm sure, you know, as Crossplane evolves, you know, people will start to build on its APIs in a similar way. Whereas with a deployment pipeline, it's hard to achieve the level of stability and compatibility and so on, where you could actually successfully do that.
And Brian, what would you say to the person that's writing, let's say, you know, a Terraform module or even a Ansible playbook, and they look at their, you know, if statements and for loops and say, look, I already have what you're talking about. What's the difference there?
The difference, I think, is, yeah, you can write a controller for an API in Kubernetes and have similar logic as to what someone would write in a Terraform module. The thing with the Terraform module, the interface is effectively the input variables to that module. You know, that's kind of the de facto API, but it's not a formal API, right? So I actually don't see people really building on top of input variables and treating those as APIs. It's really more of a human-oriented interface rather than an automation-oriented interface that people will build on. The other issue is a lot of times these modules are hard to make reusable. So, you know, people write the modules to solve the problem that they have, which is, the right thing to do. That's the problem in front of them. And they're good for that, but in order to be reused, they need to be generalized so that they can be useful in multiple scenarios. And the mechanisms that they have to bring to bear to do that are not really designed for that. So, a common pattern I see across all tools, not just Terraform or Ansible, but all these configuration tools, is that the more widely used a template is, the more parameters get added until basically every single line is parameterized of the template. It's like a pervasive pattern. It happened in Borg, it happens, in Helm. And it's really that push for flexibility so that the template can be reused. But at that point, the complexity of the template increases and the usefulness it's providing over the APIs underneath actually degrades, reduces until it's just actually getting in your way.
So when I think about the Kubernetes API, and I think when most people think about the Kubernetes API, they hear YAML. Like it's almost like a death sentence for a lot of people. YAML, YAML, YAML. And the first person to really challenge the notion, I think that even though you could always write your things in JSON, but not sure that was any better. I remember Joe Beda and team, introducing KSON, and like there has to be a better way than dealing with all the boilerplate of specifying every single, nuance of a Kubernetes config. I guess, Joe, early on, what were you thinking when you introduced KSON, and how has things evolved, right? We always refer to YAML as like the assembly language of Kubernetes, and we needed these higher level tools on top.
Yeah, I think, as we were creating Kubernetes and open sourcing it, I think just by necessity, we couldn't do it all. And from the get-go, we recognized that the API surface area, building something that was built to be built upon, was an absolutely critical thing for us to get right out the gate. And so what that meant is that the interface for the initial APIs were really meant to be verbose and explicit, because that's what you want when you're driving something from other, when not humans, right? When other programs are driving things. With the idea then that over time we could actually fill in the details and provide a higher level way of actually, configuring that. So the first order was making sure that we had something that was predictable and explicit. Things like, spec and status were lessons that we learned from the experiences in, say, building the GCE API. And that really helped to influence this stuff moving forward. I think what surprises me is, and I think one of the lessons that we've learned is that I don't think there is one true way to actually wrangle YAML. And I think even inside of Google, when we look at some of the precursor systems, there wasn't one true way. And so I don't think it probably shouldn't have been a surprise to us that that's not the case for Kubernetes also. But instead, I think what we find is that there's definitely different solutions that make sense for different users at different levels. And I think this mirrors a lot of the config discussions that we've seen over time, where it's like, hey, I just want to do something simple, to I make it fancier and fancier, it becomes Turing complete. Okay, let's start the cycle all over again. And I think that's a well-worn path that I think folks understand. And so the approach that I think really makes sense is to, number one, recognize that there is no silver bullet. And number two, how can we take this space and break it down into smaller composable chunks? Really take a tool chain approach to it, in terms of separating out, what do packages look like? How do I transmit those things? How do I have different ways of essentially generating the raw config that we push to Kubernetes? How do I have tools to be able to push that, with the idea that we can leave room to be able to mix and match these things as they make sense? And then along the way, I think what we find is that we start to blur the lines between what's happening client side and what's happening server side. And I think that's really starts getting into like, hey, if we do some of this stuff client side, there's a lot of freedom and there's a model around it. But then can we actually take that same thing, package it as a controller or an operator or whatever you want to call it, and actually do that sort of that resolution server side? And I think we're still figuring out, I think, as a community, in terms of where that line really needs to exist and when it makes sense to do one versus the other. And so I think that's a really exciting place that we're in right now.
You said something super interesting that I think it takes some people a long time to really value and recognize, which is this split we have between the specification of the resource and the status of the resource. Maybe give a little bit more detail about why that's significant and how all the other dependencies or other observers of those resources leverage things like the status field to do their work.
Yeah, I think you know, this was when we were starting Kubernetes. This was something that we introduced into the first API. We didn't call it spec and status. We called it, what do you remember, Brendan or Brian? What did we call it? It was called desired state versus
Yeah, it was desired state and current state, I think.
current state, something like that. Yeah,
And I
spec
think
and
it was
status
only in
rolls off the
pods.
tongue better. What's that?
I think it was only in pods. I'm not
It
positive.
was only in pods, I think, to start with. But this was a lesson from GCE, because when we were designing the GCE API, I think it was confusing for users that, hey, after you create a VM, what are the fields that you can update? What fields are actually output fields that the system tells you? And it wasn't really obvious in terms of what the modality was in terms of how you could operate with these things. And so the natural thing was to split this out into spec and status. And as we solidified on the sort of reconciler model, it became much more clear that reconcilers read spec and write status. I think it's that served us really well, but there's definitely places where it doesn't work quite as well, especially when you have multiple parties operating on the same resource at the same time, right? And so I think the biggest example of this would be something like the autoscaler in Kubernetes, right? If you go through and push a replica set that has a number of replicas set on it, and then the autoscaler goes through and modifies that, and then you push a new version of that replica set, well, that replicas field, who wins? You really want the autoscaler to win, but there's a good chance that you're going to actually override it and whack it. And so, one of the most complex sort of frontiers that we're dealing with right now is how do we handle that multi-parties writing it? And I think, we're in transition to server-side apply that starts to deal with that. And there's all sorts of stuff in kube control apply that to work around these types of issues. So it's one of the most complex things that we're dealing with, where spec and status starts to break down when you actually have more parties than just the writer and the reconciler coming together to define the resource.
So we went into some detail over a lot of things, and Bassam, you just kind of gave the opening keynote of what this whole vision is around having control planes. But maybe a quick answer here. Why did you start with Kubernetes? You could have leveraged a whole different type of API on top of Kube. In some ways, why, I guess, intentionally leak the KRM through and leverage it for people to make new resources on top?
So I think the motivation there was that Kubernetes was really popular. It's being used by a number of companies and organizations, and there was a really healthy ecosystem around both the writing controls. We saw things like Kube Builder and Operator Kit and other approaches, as well as the ecosystem around the tooling, Helm or KPT or JSONet, or pick your favorite tool on top of Kubernetes API. And so it made a ton of sense to actually tap into that rich ecosystem and leverage the familiarity of the API itself. And so we didn't have to deal with any of that. We basically, started with, look, let's assume the control plane exists. Let's assume the control plane is strong. And thanks to the Kubernetes community, that became more and more of a priority, with adding things like CRDs and controllers and standardizing on these patterns. And so we got to focus on how do we add, thousands of CRDs that are useful and controllers for them that are robust, so that we can empower the ecosystem to do even more with what we did with Crossplane. So that's kind of the approach we took. You're right. You could have started with something else, but I didn't see a reason why we'd have to. You're on mute, Kelsey.
We're going to go super quick here. So I want to if there was something we could change, and we're just going to wrap up with this. This Kubernetes API has enabled a whole ecosystem of, we see CI/CD systems built on top. We're seeing storage frameworks. We're seeing all these control plane tools in the cross-plane world. Brendan, if you were able to think about something that we've missed or we would do differently, what would that be? And then we're going to go with Joe, and then we're going to go with Brian.
Well, I'll be super quick. So I help author a bunch of the client libraries. And that's still a place where if you want to build a really high performance operator or you want to build a really high performance client in any way, there's a bunch of stuff that was hand coded into the client Go library that is unavailable in those libraries or had to be re-implemented. We've re-implemented a lot of it in Go, and we're starting to do it in .NET also. I kind of wish at some level that we had, and I don't know what the right answer is, maybe it's some sort of sidecar, but thought a little bit more about how we could make polyglot high performance clients as part of the API. And some of that's like server side apply, maybe it's pushing some of it into the server, but that's definitely something I think we should have thought more about, like what's the client experience, especially for high performance operators.
And we'll go with Brian next.
Yeah, I think one thing we found with trying to build very general purpose clients on top of the source model is that there is not enough consistency. Like we made certain things consistent, like the operations are consistent, the metadata is consistent, but as Bassam described for Crossplane, they had developed additional conventions to create even higher degrees of consistency. For example, cross references between resources are very inconsistent in Kubernetes. They're expressed in different ways, and it's not possible to find them automatically. Similarly, if you're doing, for example, apply on several different resources of different types, how do you know if it was actually successful? Status is reported in almost every resource, but it's not reported in a consistent way. So the client actually has to understand the semantics of the resource type to interpret the status. So a generic tool can't do that. It has to work for arbitrary types. So there are a few things like that where an even greater degree of consistency would have been extremely valuable. But we didn't set out to build a control plane just as a piece of infrastructure. We set out to build a container platform. And the control plane was kind of an important design consideration, but it was not the primary focus. So, we'll keep working on it and keep, addressing these issues. And, the broader the ecosystem becomes, the more critical it will be. And, but luckily with the model we have, it's possible to do that. It's possible to, create new API versions, add new properties to existing APIs, and every release continues to get better and better.
And Joe, we'll give you the last say on this particular question. Looking back over Kubernetes, what would we do different? Maybe some of the things that we didn't, hit a home run on. What would those things be?
Well, I think from specifics, I think the service thing was something that is too much of an overloaded object. Just talking about specific Kubernetes things, I think there's work going on in SIG network to start break that down into smaller pieces. But I think the overarching thing is I wish we had actually done what Brian said we didn't do, which is actually think about the control plane as a separable thing from the get-go. I think in retrospect, like one could theoretically, with enough time, energy, and elbow grease, take the API controller and create sort of the generic universal control plane. And I think that's probably a worthwhile effort, and remove all the containerness out of the control plane so that it's something that sort of exists as a utility. And I think if we did that in a clean way, we'd find that it gets used in much more places than right now, because I think a lot of times people think about, well, I have to run Kubernetes to actually get this control plane. Well, what would it look like to actually have a control plane without having the container management stuff as part of it? I think if we had that as a composable block, we'd be in a really interesting space now. It can still be done, I think, but it's just so much of the work that we've been doing over the last several years has been uncontainerizing the control plane over time.